طيب الآن عندنا حكينا على data view variable view، عملنا شوية manipulation وعملنا شوية recoding، حكينا على ال frequency distribution، حكينا على ال chi-square distribution، حكينا على ال comparison between two means using the t-test، حكينا عن 95% confidence interval، وحكينا على ال ANOVA وال post hoc analysis comparing multiple means using ANOVA which is analysis of variance. اليوم راح نحكي شوي على شيء اسمه regression. هلا regression it's a bit complicated. I'm not expecting students to be able to perform regression because it's something you learn as you go. It's not something you learn in a SPSS class. You need to know exactly what your data represents and what does it imply, what does it actually measure. So حكينا امبارح على السوشيال ميديا وحكينا مثلا على الديبريشن، فالآن بدنا نشوف depression والسوشيال ميديا recoded، بس نعملهم frequency distribution على analyze descriptive statistics frequencies. بندخل بالباكس اللي هو السوشيال ميديا recoded اللي عملناه امبارح والديبريشن recoded. طلع لنا two variables، ما عنديش missing cases، total is 1404. okay. الآن السوشيال ميديا is 3 categories: almost, never, rarely. The utilization of social media as the main source for COVID information اللي فيسبوك والتويتر. والdepression depression عندي 3 categories، لا بدي depression تبع 2 categories اللي هو yes و no. برجع بعمل depression، بدور على depression yes no، هيو موجود تقريبا بالثلث الأخير من الداتا. اوكي فهي أول تيبل بشوف each individual variable distribution of social media with distribution of depression. هلا هاي yes increased depression level after COVID-19 وهاي no it didn't change or did not increase, it stayed the same or even decreased. Now we go and do a cross tab. We do a cross tab between depression. If you click D depression recoded, it's D depression yes no, and this is going to be the outcome variable. I want to assess the social media effect, which is going to be the last variable. حكينا بدنا ال percentages by rows، بدنا statistics chi-square. Okay. So there is no significant relationship between depression and social media utilization. Let's do 76, 23, 78, 22, 77, 23. So as you can see, the distribution of these two variables, there is no relationship between depression and social media utilization for these 3 categories. Because those who watch social media as a main source of information for COVID had a depression of 23. They watched it all the times. If they did it some of the times, it's 23, and if they never did, it's 22. So these differences are not statistically significant. Let's look for something else. Let's see descriptive statistics, cross-tabulation, and instead of depression, let's see panic. And let's do loneliness, nervousness, and insomnia and shallow sleep. Let's do all these variables. Okay. So panic, those who utilize social media as a main source of information all or most of the time, they have a panic level of 28%. Those who never, they have a panic level of 15%, and those who rarely or sometimes do it, they have a panic level of 20%. So there's a difference between 15, 20, and 28. There's a difference in the distribution of these numbers by panic level and by social media utilization, and this is the p-value. This was statistically significant. Loneliness is the same. There's a relationship between loneliness and utilization of social media. This is the p-value, 0.003. Nervousness is the same. Insomnia, there's nothing. So let's just stick to one.
دكتور غلبك بس عندي سؤال على هذا الشيء. هلا عندنا احنا حكينا فيه significant انه بالسوشيال ميديا واللونلينس مثلا، تمام. هلا بس الكاي سكوير هذا هل بحكي لنا انه في significant مثلا انه بالاول ذا تايم 40% مثلا بتكون انه اكثر من النفر، ولا هذا ما بفرق لنا بينه؟
لا، هذا بحكي لك انه ال 40% وال 40.8 وال 32.3 وال 31.7 these are statistically significant or they're statistically different from each other. It doesn't give you an indication انه ال 40 اعلى من ال 32 ولا 31 اقل من ال 32. ماشي، ما it doesn't compare these three values.
هلا لو بدنا نقارنهم نستخدم
نروح على نعمل نستخدم ايش؟
البوست هوك تيست اللي امبارح حكينا عنه، مظبوط.
البوست هوك تيست موجود بالانوفا. الانوفا compares means. انا ما عندي means هون، انا عندي هون counts. انا عندي هون النمبرز اللي شايفها انا هون it's counts, it doesn't represent means, so you cannot do post hoc. بنعمل اللي هو regression analysis. regression analysis it takes into account regression analysis it takes into account انه عندي انا outcome variable that is yes, no. This is called binary variable. Binary variable is it has by two values, yes or no. Okay, so gender could be a binary variable. It has two values. It's male or female. So if I ask you the question, what is your gender? You answer male or you answer female. Or the question could be, are you male? So if you answer yes, then you are male. If you answer no, then you are a female. So any binary variable that has these two outcomes, yes and no, we can conduct what's called by logistic regression. Now we have here also the independent variable, the variables that we want to assess the relationship between it and between the outcome variable. So here we have social media utilization, okay, and the variable here that we are assessing, we said panic, yeah. So here we are assessing panic, yes and no, with social media. Now social media comes into three categories. Is all the time, ever, it has some time. It comes into three levels. Now with the regression analysis, with the logistic regression analysis, the numbers are going to be represented as odds ratios, or what's called by odds ratios. Now the odds ratios is a ratio, it's a representation of an actual risk. Not a measure of risk, it's an estimation of risk. Odds ratios are not a direct measure of risk, they estimate the risk. It gives you the odds or the probability having panic attack of having the outcome if you are in any of these three categories compared to one of these three categories. So when we say compare, then we have to have a reference group. Okay, and then we compare the odds ratio 1 here with the odds ratio 2. So the odds ratio presents the ratio is a number divided by a number, okay, of being in one of these groups, some or never, compared to the reference group. So this is the reference group. So what's the risk, or what's the probability, or what are the odds of having panic attack if you never use social media compared to those who use social media all the time? So this odds ratio 1 compares the risk or the probability of developing the outcome in this category to the probability of developing the outcome in the reference group. Okay? So are we clear on this? So an odds ratio is a measure of risk, or is an assessment of risk. It's not a direct measure of risk. It gives you the probability or the odds of having one of the levels of exposure, okay, compared to the one reference group in the category in the exposure. It gives you the probability of developing the outcome. So it gives you the probability of having panic if you never watch social media as a source of information for COVID, compared to those who watch it all the time. Okay? So to do this, what did we agree upon? We're gonna do the let's see the panic. Okay, so now yours could be different than mine, so the menu could be different. So I want to go to regression, and within regression, I want to hit binary logistic regression. Binary logistic regression. Okay. Now, can you find binary logistic regression under regression? You do, just click on it. Okay. Let's see if you can find it. Okay. So here we said we want panic. Panic, yes and no. So by logistic regression analysis, is a variable that has yes and no. Yes and no. Before we continue, let's go back and look at, we go to the variable view and we do anxiety panic attack. Panic attack, 0 is no, 1 is yes increase. So I'm predicting, or I'm finding the odds of developing the 1. So I'm finding the odds of having an increased level of or increased level of panic. We're talking about panic or loneliness. Okay. So are you predicting the move from 0 to 1? You're predicting the risk of developing the disease if you move from 0 to 1. If you are developing the increase or the yes or the higher level of panic compared to those who do not have it. So you are jumping between from 0 to 1. So you're predicting the 1. You're predicting the increase. Okay. طيب. So what we did is we picked up the panic, yes and no. So logistic regression analysis predicts or gives you an indication of the estimation of the risk, which is the odds ratio. Now the odds ratio of developing the outcome variable under label 1. So the yes should be label 1. So if you do not smoke, then you are labeled 0. If you smoke, then you are labeled 1. Okay? So it gives you the odds or the risk. I don't like the term risk, but it's the odds of developing the outcome, the risk of being a smoker, the risk of developing panic. So now you can do it 0, 1, you can do it 1 and 2. It will take the minimum number as the 0 and the highest number as the 1. Now for the covariates here, which are the variables that we are using, we're going to use social media. Okay? Now social media is a categorical variable. So we have to say this is a variable. It has 3 distinct categories. 3 distinct categories. Now, which one you want the reference group? I want the reference group to be the first one. See how this is going to change when I hit change. Okay, so I want the reference group to be the first one. So when doing regression analysis, you have to pick up the reference group, make sure you are predicting the yes. Okay, this is the reference group, you're predicting the panic, and this is going to be the issue. And here we are just going to fill the numbers. Okay. Continue. So we came to categories, moved this into a categorical covariates, changed it into the first, continue, and options, we want the 95% exponentiate the beta, or we want the 95% confidence interval. We want the 95% confidence interval, we keep everything as is, and then we hit OK. So all these are the outputs of the regression analysis. Okay, 0 missing cases. Okay, the outcome variable has been assigned as a 0 and 1. We already have it as a 0 and 1. Okay, distribution of the variables. So this gave us a new coding. It gave us a new coding. We don't need it. We just need to look at it. So if you score all the times, most of the time, you are assigned a 0, 0. If you scored never, you are assigned a 1 and 0. If you rarely, you are assigned a 0 and 1. So it gives us 3 main categories. Now 0 and 0 is not going to show up in the equation because it's going to be the reference group. Okay? And here is what we need from the table. So this exponentiate beta is the actual odds ratio. Okay. And this table, we said social media. If you look in here, social media has three levels. The first one was considered as a reference. So this is the reference. And then we have never, and then we have rarely sometimes. So the reference is not going to show up in this table. Social media as a variable, this is the first one. Social media as a one single variable. And social media 1, which is going to be never. Social media 2, which is going to be sometimes. Okay, so if you smoke, your risk of developing lung cancer will be 2 times higher than those who do not smoke. So if you smoke, if you smoke, if you are a smoker, then your risk of developing lung cancer will be 3.5 times higher than those who do not smoke. So this reference group has a risk of 1 because it's compared to itself. Now if you smoke, then your risk of developing lung cancer, the outcome variable, will be 3 times compared to those who do not smoke. So smokers have a probability of developing lung cancer 3 times higher than those who do not smoke. Okay, so within this concept, now we're going to move to the concept of the panic. And this is all the times. Okay. So this is going to be the reference group. Now those who never watched social media as a source of information, according to this table, they have a risk of 0.4. So when the risk is more than 1, you have a higher risk. When the risk is less than 1, you have a lower risk. So those who never used social media as a source will have a 0.4 risk, will have a lower risk of developing panic compared to those to the reference group. We said the reference group is all the times. Those who never use social media will have a lower risk of developing panic, and this lower risk is estimated as 0.462. Now those who watch it sometimes, they have a 0.6 times lower risk of developing panic compared to those who watch it. Okay, now let's go back and do the same exact thing. Regression, binary logistic regression, and categorical variables. So we have included the figure in the data set. It was all as the main source of outcome. What if we change this into the last? So it will take the last category. Now the last category is going to be what? Rarely or sometimes. Okay. Within this table, we'll just go here. Exponentiate the beta is going to be the odds ratio. And this is going to be the first one. It's going to be all times. And one is going to be never. Now, the reference group here, as we indicated, is going to be the last one. Now, the last one is rarely or sometimes. So it's going to compare all the time to rarely or sometimes, and it's going to compare never to rarely or sometimes. So if you watch social media as a main source of information for COVID, you'll have a risk of 1.5. You have a higher risk of developing panic. I think we're talking about, yeah, panic, compared to those who rarely watch it. If you never watch social media, if you never do that, then your risk is lower. Your risk is less than 1. So you have a lower risk of developing panic. So this is one way to look at what's called by regression analysis. Now, regression analysis also gives you the 95% confidence interval. We said 95% confidence interval, this is for the odds ratio, is if I do repeat the same study 100 times, then 95 of these 100 times, when I'll be repeating my study, I'll get an odds ratio between 1.18 and 2.03. The odds ratio here is 0.81 and 1.09. Now note that the odds ratio here was significant The odds ratio here was not significant. So comparing never to rarely, the comparison was not statistically significant. The odds ratio is not statistically significant. However, those who watch all the time compared to those who rarely watch it, they have significantly higher risk of developing panic, Okay, so this gives you an indication of the individual effect of each label, within the social media utilization and its effect on the panic. Now, logistic regression is actually way meaningful than this because it gives you the effect of more than one variable. It tests the effect of more than one variable. So let's just add the university. Let's do medical year. And I've added 3 variables. I've added the social media, the university, and the year of medical education, which is the basic years, I believe. This should be basic years. Yeah, basic versus clinical. I want to see the effect of these 3 variables. Now, each of these variables will have an effect on panic levels. Each of them will have an effect on panic levels. However, when you combine them together, some of these effects will be removed. Okay, some of these effects will be removed. Now, this is what's called by control of confounders. Now, if we are assessing the effect of cigarette smoking on lung cancer, okay, we'll see that cigarette smoking is associated with lung cancer. Those who smoke cigarettes will have 3 times higher risk of developing lung cancer compared to those who do not smoke cigarettes. However, if we move this analysis and said, okay, I want to assess the effect of drinking coffee on lung cancer. So drinking coffee is associated with smoking because those who smoke will be those who drink coffee. So even though I'll be assessing drinking coffee, at the back end of the burner, I'll be assessing cigarette smoking. So you are measuring one variable, however, you are actually expressing another variable. You are measuring the effect of cigarette smoking by asking about coffee drinking. So this is what's called by confounded relationship. So this relationship has been confounded. The actual effect should be for cigarette smoking. However, I'm asking about not cigarette smoking, I am asking about coffee drinking. So coffee drinking kind of confounded this relationship. Now, this was a clear example, but we have no clue what factors play a role in some outcome variables. For example, the whole relationship between cigarette smoking and lung cancer could be confounded by genetic factors. If you have that gene, then you'll be susceptible. That has nothing to do with cigarette smoking, except that if you smoke cigarettes, you probably have that gene. You'll have an addiction, and that gene is responsible to give you addiction to cigarette or to nicotine. That specific gene was actually going to be causing the lung cancer. It has nothing to do with cigarette. This is one of the hypothetical situations where what you are assessing is different than what you are actually measuring. So you are assessing coffee drinking, but you are in fact measuring cigarette smoking. So you have a good representation. Data is significant, but there's something in the background that you have no clue what it is. So we want to assess the effect of social media, university, and year of medicine, and attended any lectures about COVID. So there's a factor here that says, have you attended any lecture about COVID? It's not going to go. categorical lecture attended about COVID. Okay. So, is panic associated with social media, or is it associated with the university you're studying in, or is it associated with the medical school year, basic versus clinical, or attending lectures related to COVID? Which of these factors will affect the panic level, or will predict having panic? Now, it could be that those are the medical years of the medical school have attended more lecture. Maybe you've attended a lecture for Dr. Weil, and or you chit-chatted with him, or you talked about it with him. This will give you a yes into being a clinical, and then a yes into attending medical, into attending lectures, and it's going to give you probably a yes into being a just student. Okay. Now all these factors will be leveled, and the effect of confounders will be removed if we conduct an analysis like this using logistic regression analysis. That's why logistic regression analysis is going to give you not the odds ratio, but what we call as the adjusted odds ratio. So we are assessing the effect of social media after adjusting for the university, the medical year one, and the lectures attended. It gives you an indication of which of these variables does have an effect on panic, and which one actually does not have an effect on panic. If we hit categorical, we did all that first. Okay, so the first thing is going to give you the variable coding. So this one, it has 6 values. The first one will be the reference group, the one with the zeros is going to be the reference group. So Al-Balqa is going to be the reference group. Almost all the time is going to be, rarely sometimes it's going to be the reference group. Medical year here, the basic medical education will be the reference group, and attending no lectures will be the reference group. So let's do, this is going to be a reference. We can change it if you like, but just keep it as is, reference. And here this university is going to be the important for the, so this is the table that we are looking for. So this is what's called by the odds ratio. And we say it's going to be adjusted. Adjusted odds ratio means you are controlling for the confounders. We don't know if any of these could be a confounder for the relationship between any of these and panic. Okay, so, and this is the p-value. Social media, we said social media. If we go back to the table here, the reference for social media is the last one. It's going to be rarely or sometimes. So social media, the reference is going to be the first one. We just add the first one as a reference. So the reference is rarely. Okay. It's going to be all the time. University, this the university will be number 1, and let's go back. It's going to be Hashemite Jordan. Just is going to be the number. Just is going to be number 3. So this is going to be just. Education, we said this is going to be the one for the clinical. And this is, and have you attended? This is yes, I have attended. It's going to the variable we're looking for. So we are assessing these effects. So if you have watched social media as a source of information, you have 1.5 times higher risk of developing panic compared to those who rarely watch it. This was statistically significant. Those who never watch it have a lower risk, but it wasn't significant. If you are a student adjust, then you have a higher risk of developing panic how compared to Balqa University. However, this was not statistically significant. Okay. If you are a student in the clinical year, then you have a lower risk of developing panic. You have a lower risk of developing panic. So the risk here was 0.550. And if you attended the lecture, your risk will be 1.2. You have a higher risk of developing panic. However, this was not statistically significant. So we want to do the same exact analysis, but we want to get rid of the 0.550 here. So we're going to switch the reference group here to be the clinical. Now we are comparing clinical students to basic medical education students. To give it more sense, we will do categorical, basic versus clinical. We want to move this into the first one. So we are, hold on a second. Versus. So this is the first. I want the last one to be the reference group. Regression, binary logistic, numerical. It's going to be the same table, nothing has changed, but if you are into let's just double check this. Which one is the reference? So the clinical will be the reference. Here, the clinical year will be the reference, and I'm comparing basic to clinical. If you are at the basic medical education, year 1, 2, and 3, then you will have 2 times higher risk or 2 times higher probability of having panic due to COVID compared to those at the clinical year after controlling for the effect of social media, university, and attendance of lectures. So this example gave us the odds ratios, the adjusted odds ratios using logistic regression analysis, okay? If there's any variable you are interested in assessing, we can look into that. How about the buying mask? Wearing a face mask and using disinfectants, and if they will actually affect wearing a face mask, this variable was coded as never, rarely, and all the time, often all the time. Using disinfectant is the same. We used never as the reference group. We said the first one will be the reference group. So the reference group here will be never. And we are comparing the risk or the odds ratio of rarely, the odds ratio of often all these two values use infectant and their effect on having the panic symptoms. Okay. So here's the table. Here's the adjusted odds ratios. You are wearing a mask. We said this is going to be the reference, which is never. Okay. So this category So SPSS decided it's going to stick to this table. Let me see if I close it, what's going to happen. It's not even closing. So this is going to be the table. I'm not going to click on the table. I can't click on it anymore. It's just going to jump to the top table. So if you are wearing a mask, 1 and wearing a mask 2. So the reference group is never if you wear a mask sometimes and if you wear a mask all the time. If you use disinfectant 1, which is most of the times, and then 2, which is all the time. If you use a mask sometimes, then your risk of having panic is higher, which is 1.3. However, this was not statistically significant. If you wear a mask all the time, then your risk of developing panic will be 2 times compared to those who never wear a mask. So if you look at a medical student now and you see them wearing a mask, then they probably have 2 times higher risk or 2 times higher probability of having panic symptoms or of self-reporting or self-reported panic levels. If a person, this is if they wear it all the time, okay? Now, if you use disinfectant all the time, which is 2 here, then the odds ratio or the probability of having panic attack is 1.3. However, this wasn't statistically significant. This wasn't statistically significant. Okay, so now we can okay. So you can see that what we are trying to assess here is a statistical relationship. So wearing a mask all the time will be associated with having a higher level of panic attacks or self-reported panic compared to those who never wear a mask. This is called statistical association. We're not saying anything about cause-effect relationship. So this is not causation as in a cause-effect relationship. This is just a statistical association. So these 2 factors, these 2 variables will come together. So it gives us an indication. It's like a screening test, a screening tool. If a student has been seen wearing a mask 24/7, they probably have some issues that coexist with wearing that mask, which could be panic attack, self-reported panic. Now they may or may not have panic because panic needs to be diagnosed using specific tools. Here we just had self-reported panic. Let's see if we add some more variables. We said disinfectant. Cleaning, disinfecting phone, avoid public gatherings, staying at home, avoid eating outside. Let's see all these. All these need to go here first. Now the table has, as you can see, the table has grown to be really a massive table. Now, this is affecting the effect of social media, university, clinical versus non-clinical years, attending a lecture, wearing a mask, using disinfectant, avoiding contacting with certain group of people, okay? Cleaning, disinfecting phones, avoiding public gatherings, and avoiding eating outside. So this relationship has become way bigger than what we actually wanted it to be. And the more variables to add to this relationship, the more problems you're going to have, because this is going to affect the relationships that you are assessing. Now, some of these factors, for example, wearing a mask and using disinfectant, these factors go together. Now, again, we are assessing statistical association. We are assessing statistical association. We are not assessing cause-effect relationship, okay? So at one point in time, we have to reconsider this list of variables, because if you remember when I asked you about drinking coffee, then there is a back-end question of, do you smoke cigarettes? Even though I'm asking about coffee, I'm actually assessing probably cigarette smoking. Take this hypothetical example and apply it to something that we do not know, such as genetic variables. Even though I'll be asking about cigarette, my actual measure will be the question about, or the genetic testing, which will have addiction. So this is a genetic mutation that may provide mutation for you to get addicted to cigarette. That's why you'll be smoking. And that gene will be responsible for the developing cancer. It has nothing to do with cigarette. This is one of the examples. That's why when we see the relationship between cigarette smoking and lung cancer being assessed, remember, this is a statistical association. These two factors, they come together. If you smoke, you have lung cancer. So if you say yes, you're probably going to have yes at the other one. This is what's called by statistical association. Statistical association is about coexistence. These two variables, they coexist together. They happen to be together. They happen to be associated together. They happen to be taking place together. Okay? It's not about cause-effect relationship. Nothing in statistics will give you an indication that lung cancer is caused by cigarette smoking. Studies will provide an association, and it's going to hint that there could be a cause-effect relationship. Because to say that something causes something, then you have to assess more than statistical coexistence, which is what we are assessing now. You have to take into account, for example, confounders, which we try to control for in these examples. But this is, again, what we are trying to prove here is a statistical association. Once we develop a statistical association, which has been developed between cigarette and lung cancer, or smoking and lung cancer, then we leave it to others to find a pathway and find the pathology, the histology, the pharmacology, the genetics, and all these other factors that are important to say that smoking causes lung cancer. So to wrap up, this is a statistical association. It gives you an indication that these variables coexist together. This is it. This is what this table is telling you. Now, each time we add a variable to this table, these actual numbers will be changing. Sometimes you will lose an association because what you are assessing is two factors. So sometimes when wearing a mask, you are actually also assessing the use of disinfectant. So these two factors are called redundant variables. They measure the same thing, and you can't just put them in one regression model like this. You have to just take one variable, because the more variables to add to the model, the more it will have an effect on the odds ratio, on the outcome variable. Okay? So this is what's called by logistic regression analysis. Okay, we have something else that's called linear regression analysis. Linear regression analysis is used when the outcome variable is not yes and no is not 1, 2, 3. It's a continuous, like when we are assessing the age, when we assess the what was it? The mental health state, the negative emotional state. This, we said this is a variable that we measure on a scale, and this is going to be a continuous variable. Now, this is an introduction to regression analysis. To be able to do regression analysis, it's not something that you want to do and add more variables, because it's going to affect your actual structure of the the odds ratio that you have. The 95% confidence interval are going to be affected too. It gives you an indication of where is the data taking you, what to look for when you are conducting a relationship between a factor such as panic, because panic could be affected by 1 million factors. It's not just COVID, it's not wearing a mask, it's not medical school, it's not the disinfectant, it's not the clinical versus basic years, okay? I'm not expecting you to be able to perform logistic regression analysis. It's just something that you know that it does exist. You can easily do it. It's difficult to interpret the data. The way you select variables to include them in the model, the way you may deselect these variables, it's a little bit complicated, and it needs way more advanced analysis. But this is when you see an article that has an odds ratio, this is how it has been done, this is how it has been assessed, and now you know the term adjusted odds ratio and what does it indicate. Okay, now is there any question? Anybody has any question? So if you have no question, this will conclude our lecture for the day, and this is going to be the last lecture. We've ended the 3rd week of community medicine class, and wish you good luck, and just try to play with SPSS and have more problems, have more issues, and Google it, and one day you'll be able to master it. Okay, good luck. ويعطيكم العافية شباب.